Bismillahirrahmanirrahim. Okay, for this recorded slide video, we shall discuss in terms of example 2, which will use PE curve as our reference to determine all the parameters that contain inside the circuit. So as we can see, so we need to characterize the circuit in terms of what is their output, peak, average, RMS, output voltage, and also their current, and peak as load current, output current, RMS current, and also their SCR. This is output, V out. This is I out, RMS, average. This is SCR, and this is P. P. Input power, P in, P out. All need to be determined. And so each of the part, the load point of view, the source point of view, and also the device point of view, we need to characterize all the behavior or the current and voltage that behave or exist inside the circuit. Okay, so given we have here input 250 volt RMS, 50 Hz load values resistance given, and also the delay angle or firing angle of 40 degrees. Okay, if you take a look at the provided PE curve, so we can see one of the we have only two sheet of PE curve for full bridge rectifier. Okay, once you have a full bridge rectifier, so let's say you need to draw the rectifier, so you just draw 4 parallel diode like this and connect to the load. Okay, all the positive connect to the load, positive load. Then the AC source will be interconnected between this internal line. So draw nicely compared to me. Okay, this is the simplest way of how to draw schematic for full bridge rectifier. Let's say we are using controllable thyristor, so you just put down the gating point or terminals of the thyristor. Okay, this is R. Let's say RL, so you just R and L here. Okay, one of the graph is to show in terms of their voltage. VOMN, V output maximum normalized. V out maximum normalized power factor. P output normalized. VON. VORN, V output RMS normalized. This is maximum, average. P output normalized. Average. This is V output average normalized. Okay. So all the acronym here will represent what does it mean. Okay. Okay, let's say we are setting the alpha or firing angle at 40 degrees. So 40 degrees is our reference alpha at 40 degrees. So here is our 40 degree setting, and 40 degree. So it means that we have to draw the straight line crossing the x-axis to the point of what we want to find. Let's say we are looking for peak output voltage, V output. Some book they write as V max, some book they write as V peak. So both are referring to the same character, max or peak. And peak output voltage, so is the maximum output voltage, V output peak. And so this is the normalized versus the peak. And if you measure the output, so the graph we draw in terms of peak. So this scale or reference is normalized of this peak value. Means that if you're looking for peak output voltage, so V output peak is equal to the normalized value that we found at that degrees, 40 degrees here, we have normalized value of 1 times the V peak that we have known or calculate. Let's say we have previously the value of RMS voltage is 240, so 240 times 2 is our peak value, times the normalized value that we found when we set our alpha at 40 degrees. So 1 times 240, so 2, we have 339 volts. Okay. This is if we refer to PE curve. Okay. Let's say if we refer to the calculation mathematic formula, so we can calculate this one by V output peak is equal to Vm. V output is equal to Vm max. Calculation. But later, if the alpha is increased, so it will be quite hard for calculation wise. But in terms of PE curve, so we can just follow the trend. Let's say if you set our alpha and due to some reason we need to reduce some more our output voltage, so we set at 120, let's say alpha at 120 degrees. So what is our peak voltage? So V output peak at alpha equal to 120 degree. 120 degree is equal to how much now? Alpha 120 degree. So we set 120 degree, draw the straight line, so we can see that it cross here around 0.87 like that. Approximation 0.87 is our normalized value. So V output peak at alpha equal to 120 degrees is equal to VOM normalized times V max. So you just write again the formula. So VOMN here is 0.87 times 2402. So how much you get? So it will be 295.3 volts. So this is the approximation value, 295.3 volts. So you can see when our alpha increase from 0 to maximum of 180 degrees, V output maximum normalized also will reduce. You set at 180, so it will reduce to 0. Okay, that's how you want to use the graph. So this is referring to the peak output voltage of the full bridge rectifier. What about the average output voltage? Just now, V output maximum peak, and we are referring to peak just now. Now, if you want to look up for average, so this is our RMS, this is our average. So this is average value. So at 40 degrees, the line we cut at 0.5 what? 0.56 like that. 0.56. At 40 degrees, normalized value we found to be 0.56. Cross at 0.56 here. Okay. So means that average voltage is equal to VON times VM, V peak. So 0.56 times 240 times 2, 190.1 volt. Compared to calculation by mathematical equation, Vm over pi plus 1 plus cos alpha, and alpha we change into radian. Instead of 40 degrees, change to radian. So we found it to be 190.7 and only less than 1 digit number. Okay, even though the values is still acceptable because we are looking at the approximation. So this is in terms of when we use PE curve, this is compared to the mathematical equations. Okay. Same goes to the output voltage average. It will reduce accordingly when we increase our alpha. Alpha increase, so the BON also will decrease. That's our V output average. What about RMS voltage? Output RMS. If looking for RMS, so this is our PE curve that we should refer to. So you can see at all the time V RMS compared to V average, V RMS is higher and compared to V average. Okay, same the method. You find the average normalized values at 40 degrees of finite angle. You times the peak, so VORN 0.68 here times 240 times sec2, 230 volt, 230.8 volt. So this is RMS voltage. In terms of current, so the graph now is looking at voltage normalized voltage power from 0 to 180 degrees. So now the graph is showing the alpha versus output normalized values of current and average current, RMS current, peak current, and the form factor. Okay, if you want to look search for peak output voltage, peak output current. So you can see here, this is all the maximum is the peak. I maximum normalized, I output maximum normalized. This is input maximum normalized. I maximum normalized, I output maximum normalized. Almost the same. I output RMS, R is RMS, average. The what's called the device, and the thyristor RMS current, thyristor average current. This is form factor. The difference between RMS and average values in the thyristor. Okay, we look for output current. What is the output current at this alpha of 40 degree? The peak output current. So we can see here, maximum output current at 40 degrees. The peak is still 1 per unit. So I output peak 1 times V peak divided by resistor value, so 16.97. Compared to calculation, so we shall get the same value because the normalized vector is 1. But if it reach after 90 degree, so you can see that the normalized value will reduce and will reduce. So maybe we shall have a little bit of deviation compared to calculation. Okay, in terms of SCR, how much the current that flows into the thyristor at 40 degree average value. You can see that I average is 0.28 at this point, 0.28. So I average in the thyristor times the ION times VM, and 0.28 that we calculate just now, we found in the graph, times the peak voltage, so we get 4.8 ampere. The load average just now is what? SCR. Now load average current. Load average current. I output is I load, average normalized, and we found it 0.58 times V max divided by R, so 4.8. Same goes to RMS, and RMS, so we refer to RMS 9.48, so much higher compared to average. Load RMS current. So the sequence or the step is just the same compared to in terms of form factor. So form factor is SCR RMS compared versus SCR average. Okay. So the higher